Hi, my name is Jefferson Chua. I'm a circuit design analysis engineer at Chipworks. Today, I will be discussing the Texas Instruments WL1283 WiLink 7.0 chip. I will be showing you the Bluetooth clock circuit as well as the IQ generator associated with this clock circuit. So let's get started. The WL1283 is Texas Instruments WiLink 7.0 device. It is one of the leading multi-band Wi-Fi chips in the market, with its major competitor being the Broadcom BCM line. As shown is the top metal layer of this WL1283 chip. Now, the chip supports the various 802.11 standards and combines Wi-Fi, GPS, FM, and what we think was the first commercial implementation of the Bluetooth 3.0, all placed in a single chip. So as you can see on this polysilicon layer, the different transceiver blocks are clearly separated from one another, with this being the Wi-Fi, and this being the Bluetooth, and this being the GPS, and probably the FM receivers here, and other analog circuits in here. With that in mind, I will focus on the Bluetooth block that we currently have in our labs and take a look at the Bluetooth clock generator. The Bluetooth block consists of a receiver, a transmitter, an amplitude detector circuit, a clock generator, and a power management unit. For this demonstration, let's take a look at the clock generator circuit. As you know, modern communication systems use in-phase and quadrature signals for modulation and demodulation. As such, this requires an accurate local oscillator outputs. The Bluetooth clock generator that I'm about to show you consists of a cross-coupled LC oscillator, some clock dividers, and several IQ generators. Let's take a look at the LC oscillator. Now, this circuit, which provides the clock signal for the Bluetooth, consists of an LC tank circuit. This is the inductor, and this is the capacitor, which forms an LC tank circuit, coupled with the cross-coupled NMOS transistors, shown here, which forms the driving part of the LC oscillator circuit. So the inductor of the LC tank is a center tap type inductor, as shown on the die image. Now we're going to cross probe between the schematics and the die image. What I'm about to show you is several layers of this die. So as I've said before, the inductor of the LC tank is a center tap type inductor. It is located in this part of the die. The tank circuit also consists of several programmable variable capacitors, shown here, these two here. So again, we can cross probe this and see where they are located in the die. These are actually finger type capacitors, and they are located right beside this inductor. Now let's take a look at the IQ generator, or one of the IQ generators. As you know, there are several implementations of the IQ generator, including the famous RC-CR network, or resistor capacitor resistor network. For this chip, the IQ consists of a master latch that generates an I signal and a slave latch that generates a Q signal. Master latch, slave latch. The master latch is implemented with a complementary transistors and a master latch circuit with this transistor and this transistor. The slave latch, on the other hand, is similarly implemented with complementary transistor pairs to include a slave data circuit, these guys here, as well as a slave latch circuit implemented using this transistor and this transistor. And again, we can cross probe where these IQ generators are. So they're actually located in this portion of the Bluetooth. So now you've seen the clock generator components. If you are interested in other schematics on this device, such as the Bluetooth receiver circuit, or the Bluetooth transmitter, or simply the power management circuit, please contact Chipworks for details on ordering the full circuit extraction on these blocks.